Hello, in this video, I will go over integration by parts. So, what is integration by parts? So, integration by part is a technique to integrate the product of two different types of functions, such as logarithmic, inverse, trigonometric, algebraic, trigonometric, and exponential function. Basically, it's used to find the integral of a product. You Integration by parts usually will be your second semester calculus. So, so for example, this is a perfect example of integrating by parts because you're multiplying two products. Here's x times cosine of x, right? So that's when you would do integration by parts. Okay, so also u substitution will not work. So that's why we have to do integration by parts. Okay, let's move on. Next slide. Okay, so let's talk about the formulas for integration by parts. So the formula is uv minus integral of v du. So I won't go over how it was how you got this, but all you got to remember is what is your u and what is your dv. So uh so yeah, just put this in your notes. It's basically uv minus the integral of v du, where u is the more simple term and dv is the more complex term. Okay. So now you know when to use it, and now you know the formula. So now let's do an actual example. So let's do example one. So we have to integrate x squared ln of x times dx. So we're definitely going to use integration by parts because we have the product of two terms, right? So it's x squared and then ln of x dx. So let me write the formula. So the formula is uv, or actually it's integration of v u dv equals to uv minus integral of v du. Okay. So first I'm going to figure out what is my u and what is my dv. So u is the more simplest term, and then dv is the more complex term. So what should I make my u? I'm going to make my u as ln of x, because if I use yeah, ln of x, because if I use my dv as ln of x, I do not know the integration of ln of x, right? So that's why I'm going to use u as my ln x. And then take the derivative of u in respect to x. So what's the derivative of u in respect to x? It's du over dx. And then the derivative of ln of x in respect to x is 1 over x. Okay. Um, I want to get rid of this dx because all I see on the formula, we need a du. So I have to get rid of this dx by multiplying both sides by dx. Okay, so the dx cancels, so you're left with du on the left, and then on the right, you're left with 1 over x dx. Okay, so that's du. Now, the next step is figuring out what my dv is. So dv is a more complex term, so dv is the ln of x, and then don't forget the dx. So our dv is ln of x dx. Okay, but the thing is, if you look on this formula, this side, we don't need a dv. We need this v, right? So how do we get v from dv? So you just take, to find regular v, you take the integral of dv. Okay? Basically, it's just taking the integral of ln of x dx. Whoops. I made a mistake. My dv is not ln of x, it's x squared. Because we just said that u is ln of x, sorry. So dv is x squared dx. And then v is the integral of dv. So basically v is the integral of x squared dx, right? So that would be, and we know how to take the integral of x squared. It's just going to be integration rule. It would be 1/3 x cubed, and I won't put the plus e yet. Okay, so we have our u, we have our v, and then we have our du. So we just put it in we just apply it in the formula. So it's u times v, so my u is ln of x, times regular v, which we solve, which is 1/3 x cubed, minus the integral of v du. So if we say our v is 1/3 x cubed, and then my du was 1/x dx. So times it by 1/x dx. Clean this up a bit. So ln of x times 1/3 x cubed. I'll just put the 1/3 x cubed first. So it would be 1/3 x cubed times ln of x minus the integration. This is a constant, so maybe I'll just put that in front for right now. And then what's x cubed times 1/x? That is equivalent to x squared dx, right? And then what is the integration of x squared dx? It's basically 1/3 x cubed. And then don't forget you have to multiply this because we took out a 1/3, so you have to multiply this by negative 1/3. And then the plus c. So when you put it all together, you get 1/3 x cubed ln of x minus 1/9 x cubed, because negative 1/3 times positive 1/3 is negative 1/9 x cubed, and then plus c. And that's it. That is your final answer. Okay, so let's recap. If we use the formula, you have to figure out what your u, and first step is figure out what your u is and what is your dv. The u is the more complex, the more simple terms, because when you take the derivative, it should be pretty simple. The dv is usually the more complex one. So we said that u was ln of x because if we set dv as ln of x, I don't know what the integration of ln of x, right? So that's why I said u as ln of x. And then take the du dx, and then to find v from dv, you just take the integration of dv and apply the formula, and you'll get this. Sometimes you might have to take the integration by parts twice. Okay, so this was a simpler example. And the next example should be a little bit more complex. Okay, I will stop here.